Corporate finance practice problem using OneNote. Present value calculation with uneven payments. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're going to be in the tab on the left-hand side. We're in the practice problems and then down in the 948 present value uneven payments section. Also note that if using OneNote, you might want to take a look at the immersive reader. Many of our presentations will also be mirrored down here with text files having in essence transcripts in them, transcripts that can be translated into multiple different languages and both heard as well as read in those languages. It makes a good complement to the presentations up top. Closing this then back out, we're going to have our information up top. We're going to be going through our calculations then on down below in the blue area. Here we have with our problems a little bit more complex than we've seen in the past. We have the present value uneven payments. What we're going to say is we have year one is going to be a $10,000 payment, year two, $14,000 payment, year three, $15,000, and then after that point, we have 7 years of basically an annuity at that time of the $12,000. Now, our goal is going to be to present value these things. So these are going to be future payments that we are imagining. We're trying to pull them back into the present value. So there's a couple ways you might approach something like this. Note that, of course, if it was an annuity that we're trying to pull back to the present value, then we could break the annuity into present value of one type of calculation. So we've seen that basically in the past. Then obviously, if you have some chunks of information like this, part of it not fitting into a standard annuity, part of it then does fit, then we have a couple options. We could do this. This would be adding up to 10 periods, 10 years in our case, the periods being years. We could simply take that 10-year period and present value each one of them using a present value of one formula. Or we could try to basically do a present value of one for these three, which we kind of have to do because they're going to be broken out, one at a time. They're all uneven. And then we can present value this one using an annuity calculation, which might be a little bit faster, but it's also a little bit easier to read depending on how long this kind of thing is and how we're going to present the data. However, when we do an annuity calculation for this one, it's going to bring us back to the beginning of the annuity. And once we get that lump sum, we'll still have to take it and bring it all the way back to year one with a present value of one calculation. So that's what we're going to focus in on here. This is where a book problem would probably pick. That's the option they would probably pick, meaning present value these three, and then present value, or use an annuity to present value this one to the beginning of the annuity, then a present value of one to take that lump sum present value of the annuity lump sum and then present value it back to period one. Also note that you could come up, if you just want to experiment with different ways, you could think, well, I could do basically an annuity for these three for the amount that is the same, like 10,000 amount, right? An annuity that would be for the 10,000 and then present value the difference, 4,500 for these two, and then do the annuity thing just like we described as well. That would be a more unusual type of situation. But also note in practice, and we will take a look at it briefly, you might just present value the whole thing here for 10 payments all the way back to the present period using present value of one and just remove the annuity altogether. If you use something like Excel, that's not too difficult to do. If you're using formulas, the easier thing to do is have as few formulas as possible. So then the method we'll look at will probably be the primary method in those circumstances. Okay, so we're going to start with the present value of one for these three, and then we'll go to the annuity for this one. So we got the present value of one. We'll do this a few different ways. I'll try to do this fairly quickly because we have seen these in the past. If you want more detail on them, go into some prior presentations where we'll spend more time on them. Present value of 1 equals the future value times 1 over 1 plus r to the n. We're going to break that out into basically a formula table down here where we're going to take the 10,000. That's going to be our 10,000 up top for period 1. And we're going to take the 1 plus r to the n. There's the 1. The rate is going to be 10%. That adds up to 110% to the period 1. Because we're just looking at this 10,000, which is only 1 year out. So we got the period 1, and then that's going to bring us to, if we take this to the power of 1, 1.1, and then if we finally take the division problem, the 12,000 divided by the 1.1, we get the 9090.91. If we were to find the amount that would be on a table, we could take this number divided by the 10,000. This is the amount that we would expect to find on the annuity table. So for the first payment that we're going to get, this first series of payments in the future that we're present valuing, the 10,000 has a present value of 9,090.91. Then the second payment, we're looking at this one, we have to present value it singularly. It's 2 years out now. So we're going to do the same calculation for it. We're going to say we have the future value 14,000, 1 plus r to the n. There's the 1, there's the rate, the 10%, there's that 110%. Once again, now taking it to the periods now, to the power of, this is to the power of 2, and it's 110 to the power of 2 because there are 2 periods out this time. That's going to give us this number, 1.12. The 14,000 divided by the 1.12 would give us the 11,570.25 about. So that means the second payment, 14,000, would have a present value 2 years out of the 11,570.25. If I took that number divided by the 12,000, we'd get this amount, which we would expect to be on the table, although the table will be rounded to 4 digits. Then we're going to go to year 3. We've got the 15,000 in year 3. Same calculation, but now we got 3 years out. So we're going to take the 15,000. We've got the 1 plus r to the n, where there is the 1 plus the rate 10%. Adding those together, we get 110%. Now to the power of 3, 3 periods. So 110 to the power of 3 gives us 1.331. And if I take the 15,000 divided by the 1.331, we get 11,269.72. So the 15,000, 3 years out, if we present value it back 3 years, we get the 11,269.72. That amount divided by the 15,000 gives us the 0.751315, which is the amount we expect to see on the tables when we do this with tables. However, it'll be rounded to 4 digits. If we add those up then, we're adding up the 11,269.72, which is the present value of the 15,000, plus the 11,570.25, which is the present value of the 14,000, plus the 9,090.91, which is the present value of the 10,000, the 3 items present valued. We're going to get to then this 31,930.88. So the sum of these payments, these 3 payments, the 10, the 14, and the 15, we've present valued one at a time, got to the 31,930.88. The second half of the problem will be to use an annuity to present value this one back to the current time period, and then present value of 1, the 1 payment back 3 years back to the current day. So before we do that, though, we'll do this calculation while the way we would do it the easy way in Excel, right? We would present value these 3 with just a present value calculation. So we would take the present value of the number of periods. I'm going back to this 10,000. Using Excel, we just say present value. The rate would be 10%, comma, period 1, because this is the one that's 1 year out. And then comma, comma, because it's going to be not an annuity, but present value of 1, picking up then the 10,000. That would give us the 9,090.91. If we did that for the second one, then same kind of thing. We'd say the second payment 2 years out, 14,000. The rate, we'd pick up the 10,000, comma, the number of periods, then 2, comma, comma, because we want the future value this time being the 14,000, that giving us once again that 11,570.25. And then we have the next one, which is year 3. So we're picking up the 15,000 year 3. We have the rate 10%, number of periods now 3, comma, comma, future value, this time being that 15,000. That then giving us the 11,269.72. These 3 then adding up to, once again, the 31,930.88. Now just remember that you can imagine it could be quite easy for us to then just continue this process in Excel for 7 more payments, all of which, for 4 years out, 5 years out, up to 10 years out, all of which have a $12,000 amount, and just have 10 present value of 1 payments and simply add them all up. That would not be difficult to do in Excel. It kind of depends on what your presentation purposes are and what would be easiest for you to read. If you're doing this in a book problem or something like that, or you're doing it by hand, then of course the formulas would probably be the easiest thing to do, and you can tell that they're trying to get you, of course, to do something with both an annuity and a present value type of calculation. So we'll do it that way because that's what they want to see most likely if it was a book problem. If it's in practice, then you're not trying to see what someone wants to see in terms of what your calculations are, but what someone would like to see that would make it as easier for them to see and understand. So we could do that with the tables here too, of course, the 10,000 up top, and then take a look at the tables, which would be 10% and 1. So 10% and 1 would be that 0.9091. So the 10,000 times the 0.9091, which is close to what we saw when we kind of calculated that table amount, meaning if I go back up top, I won't do this for each one, but we saw that we calculated at the 0.909091 and so on. If we took it out more than 4 digits, so this is being taken out to 4 digits, that gives us once again about the same number, 9.091, a little different due to rounding. The table's going out 4 digits. Then we've got the 14,000. That would be the 10 and 2.8264. So that would be the 0.8264. The 14,000 times the 0.8264 gives us 11,569.60. Finally, we have the 15,000 3 years out. So 10 and 3, 0.7513. 0.7513 times 15,000 gives us 11,269.50. The 3 added together, the 9091, the 11,569.60, and the 11,269.50 gives us 31,930.1. Similar, not quite the same as the 31,930.88 due to the fact that these 3 4-digit numbers are rounded to 4 digits and are there slightly different due to the rounding. Now we'll do the second component. So now we're looking at the second piece, the annuity. But remember that we're going to present value the annuity, which is 7 payments of this 12,000. But when we present value it back to the starting point of the annuity, which is actually still 3 years into the future. So once we get this annuity down to one lump sum present value number, we'll still have to present value it back 3 years. So let's take a look at that. We'll do the present value calculation of an annuity. So let's do that one here. And I'll just calculate it in a table type of format. We've seen it in the past, so I'll just put it into the table here. That's going to be the payment. And then we've got the 1, and I'm going to pull inside the 1 plus r to the negative n. So it's 1 plus r, which is going to be 10%, 110%. That's going to be to the power of negative n. That's the number of periods, which in this case is 7 in the annuity. So note that it's not 7 years out, it's 10 years out from today. But since the beginning of the annuity, it's 7. So 110 to the power of 7 is the 0.513 and so on about. And then we're gonna take that minus 1. 1 minus that number gives us 0.486841 and so on. We take that and divide it by the rate again, 10%. That then giving us this number to the right. And then we could take the 12,000 times that number gives us the 58,421.03. This number right here is what we would kind of expect to be on the table as well. So now that kind of lump sums the annuity. So this annuity, the 7 payments, we're going to lump sum into this value, which is kind of the value at the beginning of the annuity. But the annuity, remember, in our scenario is 3 years out from the present day. So that lump sum number, we could still use a present value of 1 to get it back to today. We're not going to do that yet because we're going to do this annuity calculation, of course, a couple more times. Now you can't see the annuity, remember, as a present value calculation. And this is useful because this is the format that you would probably use if you just present value 10 periods. But let's just first present value the annuity. I won't do the present value calculations here because you can imagine them being done in Excel. But let's say period 1, this is period 1 that represents the period of the annuity, starting period 1 of the annuity, not 1 as of the beginning of the time period. And that would be a $12,000 payment. If we present value it, I'm not going to do the calculation here. You imagine we do it in Excel. We'll do a present value calculation shortly. And then that'll give us the 10,909. 2 periods out, we have the 12,000. If we present value that, it's going to bring us the 9,917. The 9,917 plus the 10,909 is the 20,826.45. If we have the third payment, 12,000, and we present value that, we have the 9,016. 9,016 plus the 20,826.45 we had before gives us the 29,842.22 and so on. Fourth payment, 12,000, present valued at the 8,196 and so on. If we add those up, then we get to the 58,421.03, and that's going to give us, that's the same as our 58,421.03. So that's another way we can do it. Now note, this is present value, and again, back to the first date of the annuity. But you might apply the same concept if you had this running balance, which would be difficult to do mathematically, but easy to do in Excel. You might say, well, why don't I just do that for all the payments? Like the first three, for example, were uneven, 10, 14, and 15. This is why we had to use a present value of 1 calculation. And I could do this just in a table. Present value of 10,000, 14, and 15. The pennies are gone, but there's the 9091, the 20,661, the 31,931. And then we could just continue on with the 12,000 for the next periods. This time, it not starting that first 12,000, not starting on the first period, but we're going to start it on period 4, and then I'll just present value it in the same fashion and just continue on with the present values on that way, and that would give us our ending balance, breaking the whole thing out to simply present value of 1 instead of using the annuity calculation. So that's an alternative format that we can set this up in. But in any case, let's keep on going down here. We can use, of course, the formula to do that annuity calculation, which would be the present value of the rate, 10%. Number of periods would be the 7. And then the payment is going to be, we're using the payment this time because this is an annuity, which would be that 12,000. And that would once again give us the 58,421.03, bringing us back to the first point of that annuity, which we would then need to use a present value of 1 to bring back, and that's our final step to bring it back. So we'll do that after we do this one last calculation using now the tables. We're looking for 10%, 7 in terms of the period. So 10% and 7 gives us the 4.8684. So 12,000 times the 4.8684 gives us, once again, close to what we had before, slightly different due to rounding from the tables, 58,420.8. Okay, let's finally do the last part now. Now we're going to say, okay, now we have the present value, or we have this amount of the annuity that we need to bring back 3 years to the current period because that thing started 3 years out. All right, so we're going to take that as our beginning point in our present value of 1 calculation. And then we will, and here's the formula we're copying, by the way, we're breaking out down here. And then we have the 1 plus r to the n. So there's the 1, the rate 10%. There's the 110, adding the 100 and the 10% to the power of 3, because the annuity started 3 periods out. We present valued it. Now we're taking that present value amount back to the current period. And then we're going to take, that gives us 110% to the power of 3 gives us 1.331. And then if we take the numerator divided by the denominator, we're going to get the 43,892.58. And then, of course, if we looked at the table, we can take that 43,892.58 divided by the 58,421.03. This is the decimal we would expect to see on the table. So now we've present valued the present value of the annuity. We lump sum present value of the annuity, and then we took it back 3 periods to give us the 43,892.58. And that total then is the 75,823.46. In other words, this amount is the present value of the annuity, finally getting all the way back to the present, the 43,892.58, plus, if I scroll all the way back up top, the calculation for the first 3 that we did, which was this 31,930.88, meaning that's the sum of these 3, the 31,930.88, and we finally got the second part, the annuity, is what we just calculated down below. We have to add those two together to get the total amount of this 75,823.46. Okay, so let's just recalculate that a couple different ways. Simple present value calculation. This would be using the Excel formula where we would have the present value of the rate, 10%, number of periods, that would be 3 because we were present valuing the annuity we got to, that we present valued the annuity which started 3 years out, comma, because it's going to be a present value of 1, so we need the future value here. So future value, and that would be then the amount that we got from the last problem, or last part of the problem, which is this 58,421.03, the present value of the annuity that started 3 years from this period. So there we have that, and that gives us once again the 43,892.58. And then we could do it with the tables as well if we want to. So let's do the tables too. So we're looking for 10% and 3 this time, making sure we have the right table. So I always have the right table because I magically put it here. Their editors put it here. Our wonderful editors put the right table here every time. So we're going to have 10% and 10 and 3. So 10 and 3, that's going to be the 0.7513. So the 58,421.03 times the 0.7513 gives us once again the 43,892.72. Almost the same, slightly different than the 43,892.58 we got before. Why? Because the table's rounded to 4 digits.